Because of the success of the interview, James Franco has been offered two acting opportunities. That TV series that is going to last 5 years, and he will be making $15 million per year. Or there could be the interview to become the leader of North Korea. The movie could be launched in 3 years. He will be paid 90 million in that year. But there's a caveat here. There's a 1 in 5 chance that movie would be a flop, and so he wouldn't get a penny. He wouldn't get anything. So what's the difference in present value between the two alternatives? Using a 5% discount rate just to make it easy for everyone. So we have a problem here where we are trying to compare two alternatives that financially look very different. One is a one-shot payment with a certain level of risk. The other one is a relatively safe stream of income over a period of time. How can we approach this? Well, we are going to use a spreadsheet for that, and we are going to use Google Sheets. We could have used an Excel spreadsheet or any other an open office spreadsheet. They all work very similar. In our case, we are going to use Google. So how do we compare these two alternatives? Well, in alternative one, this is the TV series. We have a series of $15 million payments every year. So we have that in year one, he will be making 2 million, and we are going to have all the figures in year two. He's going to make 15 million in year three, another 15 million in year four, another 15 million, and in year five, another 15 million. And the other alternative, let's call it the movie, means there's only going to be a 15 million and 90 million dollar payout in the third year. So how do we compare these things? Simply adding up the payments is not going to help us much. It would seem that the TV series is not as profitable. It will be $75 million compared to 90. Maybe the movie is more attractive. But over time, those cash flows have different values. So when we look at them from the present perspective, we would prefer 15 million in 2 years than in 5 years. So one of the ways we can deal with this is by finding out what is the present value of each one of these cash flows. Okay, in the case of something that you are going to get at the end of year one, you are going to discount it at a discount of 5%. That means this is going to be 15 million, and this is going to be divided by our discount factor, that is going to be 1 plus our discount rate, which is 1 plus 0.05, if we are talking about 5%. So, so this would be the first cash flow that we will have discounted to the present. Now, if we look at the cash flow from year two, the 15 million, now we will have to discount it for 2 years, which means we are going to discount 15 million. We are going to divide it now by the same discount factor, which is 1 plus 0.05, so let's do directly 1.05. And now it's 2 years, so we will have to use the square of that. Okay, so, um, since it's 2 years into the future, when we find the present value, we call this present value. It's going to be a smaller number, and we can do the same thing for every single cash flow that we have over here. Okay, this is for year 3. We do the same thing for year 4. 4 and for year 5. So 15 divided by 1.05 to the power of 5. And if we add up all these present values, and we can use the sum function here, where we add up all these numbers, okay, we have a present value of almost 65 million in that. How do we go about the movie? Let's solve the number, because this is going to be the important one. Well, for the movie, the present value is going to be, and we are going to do it here. Now it's going to be 90 million. Then it's going to be divided by what? It's in 3 years, so it will be using the same discount rate, 1.05 to the power of 3. Okay, so this is going to be the value, the present value of those 90 million in year 3. Okay, so this is if we add them up using the same uh, the same model. And another way to look at it is that these other cells here are all zero. They're not getting any money at all, and when we count uh, those values, they are still zero. Okay, so if we again use the same sum function, we are going to have the present value here somewhere. So let's get into this. So we add up these 5 numbers, we get almost 78 million. Okay. But we haven't taken into account yet that although the revenue stream from the TV series, all these 15 million here, are certain, he's going to have a contract with those stipulations. These 90 million for the movie depend on the success of the movie. He has a 1 in 5 chances of failing, which means we are going to look now at an element of risk. So what is going to happen is uh, if it's successful, the present value is going to be $77.75 million. But if it fails, then he's going to get absolutely nothing. He's going to get $0 here. Now, we have to adjust that the chances of success are 80%. So his expected uh, the expected value of we can have a column here that we can call expected value uh, is going to be those 77.7 million, and we are going to use the value from that cell. But now there's only an 80% chance, and we can reduce the number, that would be a point 0.8, and that's what 80% means. Um, we have to multiply that by point 0.8. Okay, so that would be the expected value, and the expected value of 20% of zero is going to be if you're going to get you the whole formula, you're going to 0 times zero point 0.2. Okay, so now uh, when we add them up, what we have is that these expected values, now adjusting for the probability of success and failure, is actually smaller than the expected value of a certain uh, stream of revenue. So this is how we can compare uh, these two revenue streams that are quite different. In present value, uh, making movies or making a series, a TV series uh, uh, for 5 years is going to give James Franco about $65 million. Um, a bit over 62 is the expected value of making the movie. Now it's really up to you to decide whether you actually want to see James Franco on TV or